This is a 1D motion review. You should have had all your lessons by now for this unit and just trying to get some extra practice. So what are the units for displacement? Well, the equation would have x as displacement. The unit itself would be meters. For velocity, it could be VI, VF, or just V. That's going to be meters per second. And for acceleration, which would be A, would be meters per second squared, or sometimes written meters per second per second. Okay, describe the motion of the object during the 65 seconds of the motion graph. Well, first of all, you have to notice it's a position time graph, so these are talking about meters or actual locations. And from the first part, he went from 5 meters to 10 meters at a constant rate. So he had a constant velocity forward, and he stopped at 10 meters, so he stayed at that position for the whole time right here. And then he went ahead and sped back up, and even a faster constant rate forward from 10 to 25 meters at a constant rate. He's going velocity right here. So constant forward velocity, and then rest again at the 30 or the 25 meter point until 65 seconds are over. So we have constant forward, velocity, and we have rest. So rest. So there's two spots where you're at rest, right here and right there. And then two spots with constant forward velocity are going to be right here and right here. Okay, what does the slope of the position time graph tell you? This is going to be velocity. Meters over seconds, that's the slope, and that would be a unit for velocity. What is a displacement and why? So displacement is just, you can just read it off position time graph. If this was a velocity time graph, I'd have to do a little bit more. And so here you just went 5 meters forward, and you went from 5 to 10 meters, and that's why 5 meters forward would have been 10 meters. 10 meters minus 5 meters. Okay, and then 15 to 30, you're going to be at rest. So 0 meters, or you're at rest. And that's because you went from 10 meters to 10 meters, no motion. Then from 40 to or 30 to 45, 30 to 45, you are going, so that's 25 minus 10, so you're going to have 15 meters forward. And that's because you went from 10 meters to 25 meters. And then from 0 to 65, you're going to be at rest. 0 meters, and then you're going to be at rest again. And that is because you went from 25 meters to 25 meters, which means no motion. Okay, what is the velocity from 0 to 15? Okay, so now you have position time. Now you're going to have to use the information off of this and get a givens list that's going to help you solve the question. So the velocity, you went from, so just a reminder, V equals delta x over t, change in x over t. Another way of stating that is V equals x final minus x initial over time. And I'm going to go ahead and take that final 10 minus 5 and put that over 15 seconds. And so 10 minus 5 equals 5 divided by 15 equals 0.33, and that's going to be meters per second. Okay, so for 15 to 30, what's your velocity? 15 to 30, 0 meters per second, because you're at rest. And what's the velocity of the object at 35? So 35 is asking for this point. I'm going to take this entire interval, and this is going to be the same as 35. Because the slope is going to be the same the whole time. Remember, slope is the on a position time graph. The slope means velocity. So I'm going to go ahead and I'm going to take the interval v equals, and we're going to go x final minus x initial over time. I'm going to take that whole interval and I'm going to stop at, so 25 is where it stopped. Started at 10. It looked like a plus. Started at 10, and divide that by In this case, take a look, you went from 30 to 45, so that's going to be 15 as well. So what I find students do to make a mistake is when they see take it at 35 or something like that, they'll take this whole thing. Well, the velocity changed. It was at rest for part of it. It was going slower earlier, and then it's faster now. So you actually have to take the entire displacement and take it over the entire time for that interval itself. And so that's going to give me 25 minus 10 will be 15 divided by 15 would equal to 1. It does be 1 meters per second. Okay, describe the motion of the object during the 65 seconds of the motion graphed. Okay, so this is a velocity time graph now. So you're looking at different things. You're looking at as you go forward, you're getting faster. So it's not the only place you would be not moving is right at the 0 point. There's only one time where this object's not moving, and that's going to be at the beginning. So initially, first part you're going to have right there. It's going to be acceleration, moving forward. And then right here, it's going to be constant velocity. And then right there, that is going to be deceleration. But you're still moving forward. You still have a positive velocity. It's just you're changing your velocity in a negative direction. And then right here is going to be another constant velocity. And both of these are going to be forward. And that would be forward as well. And the reason why it's forward is because it's above the 0. I'd have to have a negative side to this to be going backwards for this graph. Okay, what's the instantaneous velocity at 5 seconds? Well, the good thing about a velocity time graph is that when you're asked for velocity, you can just read it. So 5 seconds right there, I would say maybe about 8 meters per second. What's the change in velocity from 0 to 15 seconds? Well, that's going to be, you went from 0 to 25, so that'd be about 25 meters per second because it's this right here. And then from 15 to 30, so 15 right here to 30 right there, and that's going to be instantaneous velocity is going to be 25 meters per second. And that's because we're just looking at that point right there, and we just take it on over, and there's your 25 meters per second. Circle my answers, and we keep on going. What does the slope of the velocity time graph represent? This is going to be acceleration. So sloping up, accelerating, not sloping, constant motion, sloping down above the 0 point, deceleration, and flat again, you have constant motion forward. What's the displacement from 0 to 15? So now we have to look at this, we have to determine is it a constant velocity. If it's a constant velocity, we use this one. And if it's an accelerated problem, which this first one is, so from this first one, VI equals 0, VF equals 25 meters per second. And we have a time for that first interval of 15 seconds. And we're solving for displacement, which is x in our equations. And we have this one equation we can use. X equals VI plus VF over 2 times time. So x equals VI, which is 0, plus 25 over 2 times that 15. And we put that in the calculator. 25 divided by 2 equals 12.5. And we multiply that by 15. And we get 187.5 meters. Once again, we were looking for x, and so meters is the unit for our displacement. Okay, from 15 to 20, from 15 to 20. Okay, so for that one, you're going to go and take v equals x over t. So from 15 to 20, you have a velocity of 25. It's a constant velocity, so we're not going to say VI or VF. We have a time of 15 seconds again, and then we have a x that we're looking for. So you rearrange this equation, it ends up being x equals vt. So v is 25, t is 15, and 25 times 15 equals 375. So 375 meters is how far you went during this interval right here. What's acceleration from 0 to 15? Okay, so acceleration from 0 to 15 seconds right here. You're going to go ahead and you can pick off your givens. Vi equals 0, Vf equals 25, t equals 15 seconds, a equals question mark. So a equals Vi minus Vf over t, a equals Vi, which is 0. So that's going to be Vf minus Vi. Let me change that. Vf minus Vi over t. And Vf was 25. So a equals 25 minus the 0 over the 15. And you get 25 divided by 15 equals, and that's going to be 1.67 meters per second squared. And so that's going to be the answer for that first one. And then from 15 to 30, you have a equals 0 meters per second squared, and that's because you have a flat line on a velocity time graph as acceleration. Then when you get to 35 seconds, you're going to have to take that whole interval right here. So for 35, we're going to try to take the information off of that. We're going to go back to, a equals Vf minus Vi over t, and we're going to have a Vi of 25 meters per second, a Vf of 20 meters per second, a equals question mark, and the time interval would be, so 35 seconds, we're going to go ahead and we're trying to find the slope of this line, the slope on a velocity time graph. And then we're going from 30 to 45, which is still going to be 15 seconds. So a equals Vf, which is 20, minus Vi, which is 25. We divide that by 15. So we're going to get 20 minus 25 equals negative 5 divided by 15, and we get negative 0.33 meters per second squared. Oh, so that's going to be negative 0.33 meters per second squared, or even better, backwards would be an answer you can use. 30.33 meters per second squared backwards without the negative, because the negative represents backwards. Okay, you throw a ball up in the air with an initial velocity of 25 meters per second. What's the acceleration due to gravity while the ball's in the air? Always going to be 10 meters per second squared down. Acceleration due to gravity when it's at the top of the flight, always 10 meters per second squared down. That does not change. Doesn't matter where it's at, how the ball gets into the air, but once it's in the air, it's changing its velocity by 10 meters per second squared down. Even if it's thrown down, still that's going to be the case. What's the velocity at the top? So velocity is what you actually see. And at the top of an object's flight, it's going to stop for a second. So it's going to be 0 meters per second. But then when it finally comes back down, it's gonna land. So by the time it goes up to the top, it stops. The whole time a equals 10 meters per second squared down. Changing it down, that's why it changes and makes it stop and go back down. But when it's caught, it's going to be caught with an opposite velocity. So if this is 25 meters per second up, this is going to be 25 meters per second down. And that's what the answer is going to be, 25 meters per second down. So acceleration stays the same. It's the velocity that's changing because of that acceleration always staying the same, which means it's changing the velocity the same way the whole time, same rate, but the velocity is changing the whole time. Okay, which has a greater acceleration once it's in the air? They are all going to be the same. Doesn't matter how it gets in the air. They're all going to be changing by 10 meters per second, downwards every second. What does the speedometer of a car help you determine? Okay, so the speedometer of a car is going to tell you how fast you're going right now. When you get to a red light and you hit the brakes, you go to 0. And when you hit the gas, you might see that car speedometer go up to 55 miles per hour or something like that. That's telling you this instantaneous velocity. There used to be a little gauge, a little needle that would turn and get higher and higher and higher. Now I think most cars are digital and they just tell you how fast you're going. How would you determine the average velocity of a car? Find out how much total it driven and divide that by time. Well, velocity is going to be a vector, so we need to know where it's located from where it began, and then also the time it took, and then we can take that and divide the displacement divided by the time. What does a scalar include? That's going to include a magnitude and that's it. And then it was a vector include magnitude and direction. And just as a reminder, this would be like 5 meters, and this would be like 5 meters, and this would be like south. And if I ever ask you just for the magnitude of a vector, you just leave off the direction. Even though it still would have a direction, you just leave it off. Okay, 10 meters east. So east is telling me it's going to be a vector. So right off the bat, I know it has to be a vector. And then 10 meters, well, that's going to be the vector displacement. So D is going to be our answer. 10 meters, I know that's going to be a scalar. And I also know that it doesn't have a direction, so that's a scalar. And then that's going to be distance right there. 10 meters per second east. Okay, so now that's going to be a vector again. But that is going to include meters per second, so that's going to be a velocity. 10 meters per second. So once again, no direction. We're going to be back to scalar. And that's going to be the scalar speed. Okay, tennis balls drop from rest from the top of the building. It takes 8 seconds to hit the ground. How tall is the building? Okay, drop from rest. So VI equals 0. Takes 8 seconds to hit the ground. It's going to accelerate because it's in the air at 10 meters per second squared down. And then we're asked for how tall the building is. So if you take a look, I have VI, I have T, I have A. The best equation I can use is x equals VIT plus 1/2 AT squared. X equals 0 times 8 plus 1/2 times 10 times 8 again squared. And so the first part is going to be 0, so I can leave that off. 0.5 times 10 times 8 squared equals, and we get 320 meters. That's how tall that building would have been. So it's 320 meters tall, or the ball fell 320 meters. So it's good to be as descriptive as possible. Okay, what's the acceleration of an object that traveled from 10 meters per second to 20 meters per second in 4 seconds? So A equals question mark. VI equals 10 meters per second. VF equals 20 meters per second. And time equals 4 seconds. So A equals, it comes from this equation right there, but it's on your equation sheet somewhere else, VF minus VI over T. So if you're solving just for A, you can just start there, or you can rearrange it, or you can find the other equation on your equation sheet that's the same one as that one, which is that right there. So A equals VF, which is 20 minus 10 divided by 4, and we're going to have an answer of 20 minus 10 divided by 4. We're going to get an answer of 2.5 meters per second squared. Once again, we're solving for acceleration, which unit is meters per second squared. Used all the MKS units going in, you're going to get an MKS unit going out. Okay, what's acceleration of an object that travels with constant velocity? This is your trick question, watch out. Constant velocity means there's no acceleration. Okay, what will be the speed of the object that's starting from rest is freely falling for, okay, so we're solving for it free fell from rest. We're trying to find out what the speed's going to be after 3 seconds. And accelerating at 10 meters per second squared down. So there's no conflicting directions, it's just down and nothing. So we're going to go ahead and our answer, if it's positive, it's going to be down. We're going to use positive values. So VF, VI, T, and A, that's going to lead you to VF, VI, T, and A, VF, VI, T, and A right there. So we have VF equals VI plus AT. So VF equals VI plus A times T, and we're going to get 30 meters per second, and we plug that in. Okay, what's the final velocity after starting from 5? So VI equals 5 meters per second, and accelerating in a straight line for 6 meters per second squared. That should be second squared up like that. So 6 meters per second squared, and for a distance of 20 meters, we're solving for VF equals question mark, and that's going to lead us to this equation right here. So we're going to have VF squared equals VI squared plus 2AX. And we're going to go ahead and we're going to solve for VF separate, so we're going to have the square root of all of this. 5 squared plus 2 times 6 times 20 times 6 times 20. And we want to have all this, the entire amount, this whole value in the square underneath the square root. So I like to type it in backwards. 5 squared equals plus, open parentheses, 2 times 6 times 20, close parentheses, equals, tells me 265, and then on my calculator I can go to the square root. I hit the second, and this is right above the squared on my calculator. If you have a TI, that's going to be where it's going to be located. And then I hit second, and the little negative at the very bottom, not minus, but the negative, there's an A and S, and if you hit that, close the parentheses after that, you can take the square root of the last answer you had in your calculator's memory. And so it pulls right back in the number from before. So VF equals 16.2, let's make it 28 meters per second. And so that's my answer for this one. Okay, how far have you ran after 5 seconds at 8 meters per second? So how far, X? And you're running for 5 seconds. And you're going to do that at a velocity of, it's a constant velocity, it doesn't say anything about speeding up or slowing down, 8 meters per second, so V equals X over T, and X equals VT. When you rearrange that, X equals velocity of 8 meters every second, so we're going to take that up 5 times because we go for 5 seconds, so 8 times 5 is going to be 40 meters. That's how far you're going to go. Okay, so last question is a two-part question. Runner starting from rest speeds up over 20 meters. So starting from rest, VI equals 0. And they're gonna trip over rocks, slow down afterwards. It's gonna slide after that. So it goes from 0 to, it doesn't tell me the final velocity yet. It says it's gonna take 20 meters to do this. And you're gonna accelerate at 3 meters per second squared. And we want to know what the final velocity is of that runner at this point. So VF equals squared equals VI squared plus 2AX. And that VF is going to be square root of VI 0 squared plus 2 times 3. And this is not acceleration due to gravity problem. He's going forward. So before you were in the ball was in the air. 20, and we're going to want to keep all this underneath the square root. So we go and we get 2 times 3 times 20 equals 120. Then we take that square root of that answer, 120, and we're going to get a final velocity of 10.95 meters per second. And so they get all the way to 10.95 meters per second. Now the second part of this question actually starts you off at the end of the previous one. So the VF before is now going to be, so the VF from before is now the new VI, because the second part starts at, so VI equals 10.95 meters per second. And so you might have many times where you have multiple part questions and you got to think, okay, so this runner is running. He's going to start off with this initial velocity of 0, and then by the time he gets here, he's going to get to this final velocity of 10.95 meters per second. And so this is like part 1. But then on part 2, he's going to trip over rock. And at this point in time, so we have a new VI, and we're trying to find out what's the velocity at the end of this part after sliding for 5 meters. So there's going to be 5 meters it goes on. So VF equals question mark. A, they tell you, is -2 meters per second squared, and tell you you're going to do this for 5 meters. So VF equals VI plus AT. Oh no, not that one. We're going to go with the VF squared equals VI squared plus 2AX. And you can't assume that this person stopped. He slid 5 meters. We're going to find out what velocity is going right now. So VF equals, We're going to take the square root of VI, which was 10.95 squared. And that's going to be plus 2 times negative 2 times 5. So when we take this final answer right here, we put 10.95 squared in the calculator plus, open parentheses, 2 times negative 2 times 5 close parentheses equals. I get 99.90. I'm going to take the square root of that. And I get an answer of VF equals 9.995. So 99, let's just go with 995. Could round that up to 10 if I wanted to, meters per second. So that's what's happening. This person's still going forward. So now when you're trying to graph a position time graph of this, what initially happened was this person was accelerating. So he was going upwards, he's going forward, he's going upwards faster and faster and faster. But as soon as he hit that rock, he's still going forward. But he's going forward at less and less of a rate. So this ends up being an S-like shape. So this is the place where he tripped. He was accelerating here. And then he was decelerating. And decelerating. Right there, always moving forward. So hopefully after being able to work through that,